hope that you are enjoying your week. Sorry I haven't been in touch for a little while, but I've had lots to do. This particular video is for those of you that came to revision session recently at school. If you're tuning in from the World Wide Web, then this will be a video that just brings together a selection of different questions of more challenging difficulty. These questions are all from Edexcel, either from practice papers or from papers that are more recent. So we'll give you some good pointers as to how to revise for the summer. If you're new to this channel, please do subscribe or leave a like. Again, explanation about the channel in case you're new to it. It's just these videos particularly are just for people revising for the summer GCSE exams. So this question ahead of us here is a vector question. You can see it's talking about a complex shape here. It's a trapezium with a little sort of edge on it, this CN, this little edge on it. And we've got a range of different things being given to us in the question, which you can see I've gone ahead there and filled it in. As I've gone ahead, I've sort of had a look and filled it in. So what have I filled in my diagram? I filled in that AD, so this length here, is 2b, the vector 2b. AB is the vector 4a, and because this is saying that this is twice as much, I'm also filling this in as 8a, and then a little bit further down it tells me that this is twice as much as that, so I filled in the 4a as well. The first question is asking me for BM, so it's telling me that the midpoint is M, and it's asking me to find BM. So underneath this paper you can see I've gone ahead and worked this out already before the video started. So you can see that I've got BC here, and what I've done is I've created a vector triangle to go from B to C. My mega hint for these questions is always to look at how to do the journey from B to C. If ever you're being asked about a midpoint or some breaker in a journey from between 2 points, find the vector that takes you between those 2 points. So that's my major hint. So I've gone ahead and worked out BC to start with. BC is going to be minus 4a, so this distance here, plus 2b, this part of the journey, and then this bit here, this 8a, which is why I've gone ahead and done that. And you can see I've put minus 4a plus 2b plus 8a in here. And then 4a plus 2b then is what you will get if you work those things out, because you've got minus 4a plus 8a, that's 4a, and then you've got the 2b carrying down from there. But because m is the midpoint, we're going to halve these two. So 2a plus is one lot of b there. Sorry, I made a small mistake before the video started, but that's 1b. Now down here in the second part is asking for DCN and proving that DCN is a straight line. So that's this distance here, so DCN, and it's asking to prove AMN, so AMN. Strategy on straight line proofs will always go as follows. Find a vector that takes you from A to M, find a vector that takes you from A to N, and then show that the vector from A to N is a multiple of the vector, or parallel to the vector that goes from A to M, but because it goes from the same point, because it starts from the same point A, they've got to be on a straight line. So you can see I've gone ahead and again worked out AM. I've used the previous question to help me, so AM, made the pattern from AM, so I've gone across the 4A here, so across the 4A and then down here, so BM, so across from A to M is 4A, and then this bit, this is the BM, the 2A plus 1B from earlier, so this is 2A plus 1B, so 2A plus 1B, and then that is 6A plus 1B here, and then AN, so the vector AN will be, again, just going through the steps, 2b here, and then plus the 8a, and then plus finally this 4a. So when you calculate that all together, you're getting 12a plus 2b. Now there's a little bit of more explanation that you need. This is showing this is a multiple, so an equals 2m is a multiple of that. It's a straight line, but I'm just going to add a little note here. It's a straight line because from the same point as well. So it starts from A. You have to state that it starts from the same point. So I will just add that in, because it's a straight line. If it's a multiple, it's parallel, but it's also, because it's from the same point, because they both go through A, they're both from the same point, so it has to be a straight line. Right, moving on. This is the second set of questions here. Again, these are just a variety of questions that were put in front of people. I just want to go through these ones. So this is the second one that we showed you. I'm just going to bring it slightly up to the camera because it's not coming out too well, so I hope you can see that. So it's 8 times 10 to the 9n, where n is an integer, and it's saying express m is minus a third, m to the power of minus a third in standard form, and given your answer in terms of m as simply as possible. It's really tiny, so I'm sorry it's coming out a bit too small. I can see on the camera it's not coming out too well, but this, just to write it down for you, is 8 times 10 to the 9n. So I'm just going to write that down, and that's what that is. And this here is m to the power of minus a third, so I'll just write that down again because it's not coming out too well on the camera. So it's asking me for m to the power of minus a third. So we need to write this to the power of minus a third. So 8 times 10 to the 9n to the power of minus a third. That's what it's asking for. Now, when you're doing bracketed expressions such as this, you must apply the power to all of the expressions. So 8 to the power of minus a third, to look at that. And then look also at 10 to the 9n to the power of minus a third. So both parts of it to the power of minus a third. Now, this is a reciprocal because it's a negative power. So you've just got to remember what reciprocal does. You've also got to remember what a third power does. A third power is the cube root of 8. So this is 1 over the cube root of 8, much like this. And then this one, again, you can multiply these two up because they're both it's in a pair of brackets. This is going to be 10 to the 9n over minus a third, so it's going to be minus 3n here. So 10 to the power of minus 3n. Now this 1 over cube root of 8, that's a half. So it's a half. So cube root of 8 is 2. And then 10 to the power of minus 3n again, you can leave that in that form. We're not quite there yet because the answer asks for standard form, and this is not a standard form because this is not a number between 1 and between 0 and 10, so, or between 1 and 10. So we need to make it a whole number. At the moment it is 0.5 times 10 to the minus 3n, and we need to make it a whole number. So we're going to make it 5. So in other words, I'm multiplying everything here by 10. But to compensate for that, because I've multiplied everything by 10, I have to take a 10 power away from this power. So I'm going to do that real quick as well. So it's 10 to the power of minus 3n and then minus 1, because I've got to take 1 away from that particular power. Over here I've got question 20. This is to do with cents and coins. So this is asking about different relationships here. Ashok, which is 6 coins in his pocket. He has 1 5-cent coin, 2 10-cent coins, and 3 20-cent coins. He takes at random a coin from his pocket, and he records its value and puts the coin back into his pocket. He then takes at random a second coin from his pocket and records its value. So this is with replacement. You can see it's putting it back into his pocket. So this is with replacement probability. So I'm already thinking this is a limited amount of choices. This seems to be a probability question. So I'm thinking tree diagrams is going to be the way to do this. The first part, not quite yet for tree diagrams. We can do the first part without a tree diagram quite easily, because taking 2-cent coins is fairly easy. So first, in order to get 1 20-cent coin, you've got 3, 4, 5. So you've got 6 coins in your pocket. So you've got 3 out of 6 to get a 20-cent coin the first time. So that's a half the first time. And then to get it again, it's going to be 3 out of 6 again. So half times a half, in other words. So it's a quarter for the first one. That's quite straightforward as a question. But the second one, we are going to need a tree diagram. So the tree diagram, we're going to need the second one. So we're going to have a tree diagram. It's going to be a 3-branched tree diagram. Its 3 possibilities are 5, 10, and then 20. And then because he takes a second coin, so second coin, we're going to have the same possibilities going out here. So 5, and then 10, and then 20. And then same here. So 5, and then 10, and then 20. And then the same here. So 5, and then 10, and then 20. So all those possibilities still there in the same way. Now, each of these probabilities need some careful thought. So to get a 5, it's 1 out of 6. To get a 10, it was 2 out of 6, or a third. And then here I'm going to write 20 again to get 20, same as earlier, so it's a half there. This was the half again, and this is a third, and this is a sixth. It's good that this was replacement because these don't change. Sixth, a third, and then a half. Hope you can see that. It's kind of teeny weeny, but hopefully you can see what I'm doing. And a sixth, and then a third, and then a half again. So each of these probabilities doesn't change. Now it's saying the second coin he takes has to have a higher value. Let's just read the question here. Higher value than the first coin. So that's what the question is asking for. It's asking for when the second coin has a higher value than the first coin. So where does that happen? Well, it happens here. So this outcome here. So 5 and a 10. So 6 times a third happens there. It happens here because you've got a sixth times a half. You've got the 20-cent coin second. Does it happen here? No, because 5 is less than 10. Does it happen here? No, because 10 is not more than 10. 10 is the same as 10. But it does happen here. So a third times a half. Does it happen here? No. Does it happen here? No. Does it happen here? No. The second coin has to have a higher value than the first coin. So there are 3 outcomes where that happens. Each outcome has a different probability. So it's 1 over 18 here, 1 over 12 there, and 1 over 6 there. And you've got to add up the 1/18th, the 1/12th, and the 1/6. Now again, I did mention earlier, this has come from the calculator exam, so you can use a calculator for these if you wish to, or you can add them up. I mean, these aren't too terribly difficult to add these 3 particular fractions up, but you should get getting used to using your fraction button on your calculator to do these things. So you're going to be adding up 1/18th plus 1/12th plus 1/6, and on my calculator there I've just shown you what that looks like. So 1/18th plus 1/12th plus 1/6, and you would press the equal sign, and I'm getting 11 over 36 there. So again, this is going to be just over here, 11 over 36, and that's your answer. Carrying on to a few more questions yet to do. So we had a couple more to do. So this question here was another one of the ones that we needed to do. So this one up here, first of all. So there are 15 boys and 9 girls on a mixed hockey team. One of the boys and one of the girls are going to be chosen to collect the cup. Work out a number of different pairs that can be chosen. We've got 15 lots of boys and 9 lots of girls. And so to choose the pairs, you're going to be choosing from the 15 boys and choosing from the 9 girls. So it's just 15 lots of 9. We'll get you the answer there. So 15 lots of 9 would be the amount of choices that you have to pick that particular pair. So 135. The next question says 2 of the boys are going to be chosen to play in all the boys' teams. Sam thinks the number of different pairs that are going to be chosen is 210. And Tom thinks the number of pairs that's going to be chosen is 105. And then who is correct? Now, you've got 15 boys, so you've got a combination of, there's going to be something involved here with 15 times 14, because you've got 15 ways of choosing the first boy and 14 ways of choosing the second boy. However, this makes 210, so you would assume that Sam is right. However, you've got to think about the fact that you can only pick one combination one way. You've got to eliminate the fact that people are going to be duplicated. Once you pick the first person, you've only got 14 ways of picking the second person, but you can only pick those 2 pairs. You can only pick that pair one way, and there are 2 ways of picking each pair because of the way that the system works. So you're going to have to halve that amount of possibilities. So it's 105. So it's Tom that's right. Okay, 15 lots of 14, but because the 2 boys are in the same team, it's an all boys team, there's only going to be you have to avoid the duplicates. The way to model that is just to try and think about how it looks. I would encourage you to think about how that might look if you were doing it for real. So it's always half the number you want to take if you're thinking about this. So if you take a little 2-way table here, you can model it on 2 boys. So let's say we had 2 boys here. You can't pick them with themselves. There's only 2 ways of that happening. So you might think 2 times 1, that gets you 2 two ways, that's fine, but it doesn't quite work all the way through. So just be cautious about the fact that when you get to 3 things, so it's this one here, so A, B, C, D, and then A, B, C, D, okay, you only want to pick one pair. So this one obviously can't be picked with themselves. These are pair, 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 pair. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, 4 3s are 12. So you might be forgiven for thinking, oh, that works, you know, like 15 times 14, that works. But here's the but. The pair of A and B is the same as the pair of B and A. That pair is the same pair. So you have to halve the amount of pairs that you've got. Similarly here, A and B is the same as B of A. You've got to halve the amount of pairs. A of C, same pair as C of A. You've got to halve that. You can't count it twice. You can only count it once. So you have got to halve it just to make sure you don't count it twice. So you're getting rid of the duplicates. You're only going to have 105 pairs. Question 17 is a ratio question. It's asking you for A to B is 5 to 8 and B to C is 6 to 25. These questions tend to come up quite a bit. So hopefully you've seen a few of these. What you need to do if you've got A and B here and C and D here, sorry, B and C rather, what you've got to do is try and find a way of relating these two middle numbers, the two B values, because they're both common to both lists. So what multiple of 8 and 6 can you pick that's a reasonable multiple? Well, 24 is a reasonable multiple. Let's look at 24. So if you look at 24, if you're multiplying that by 3, you'd multiply that by 3, 15. If you're multiplying that by 4, 'cause 6 4s are 24, then you'd have this multiplied by 4. So 25 times 4, 100. So the ratio of all three numbers together is 15 to 24 to 100. I think it probably is simple as it gets. I don't think it gets much simpler than that. You can't find a number that goes into 15, 24 and 100, I don't think. So I think that's probably as easy as it gets. Over here, question 18. Rana wants to estimate the number of balls in a bag. On Monday, Rana removes 120 balls from the bag and she puts a mark on each ball. She then puts all 120 balls marked in the bag. And on Tuesday, Rana removes 20 balls from the bag. 8 of these balls have a mark on them. Work out an estimate for the number of balls in the bags. This is a capture-recapture question. Capture-recapture questions are quite interesting because they always follow the same sort of pattern. They tell you how many are removed, they tell you what they've given back. So what you've got to think about is how many you've got. So when she picked out the ones that had a mark on them, she had 8. How many did she get that was removed from that ball, from that bag the second time? She removed 20 from the bag. And so that ratio must be the same as what you had originally. So you have to think about each time what you've got. You had 120 balls in the bag originally, and she marked them up, and that was out of the population that you had. So 120 out of the population must be the same as the ratio of those you got marked out of those you picked out. And so to work this out, you would do 120 divided by 8 over 20 equals t. This is a characteristic question with an unknown underneath, so you can swap the unknown and this number around. Your teacher might have talked about that. You see it a lot in trigonometry, particularly in sine cosine problems with missing hypotenuses. Just be comfortable with working with with an unknown underneath problem. So 120 divided by 8 over 20. When you work this out, you will get t, the total being 300. So 300 in the population to start with, 300 balls in the population to start with. Onwards and upwards. So again, this is one of the problems that you've been seeing before. So this is a speed time graph for a car. This question asks you for an estimate, so it says estimate, for the distance travelled, the car's travelled in the first 6 seconds. So what you have to recognise is that when you've got a speed time graph like this, the distance travelled is got by doing the area under the graph. So the area under the graph in this first 6 seconds. So what you can do here is you can take a ruler. You can do this a couple of ways. You can create trapezia. So you can create some trapezia here, or You could create a big triangle, just depends on how you're feeling that particular day. I think I will create 2 trapezia, might get a better, more accurate number, and then a little triangle here. So 2 trapezia and then a triangle. Sometimes it tells you how many strips to use. It hasn't here, so I'm just going to use it. It's only worth 3 marks, so I'm not going to spend too much time on it. So we've got 2 trapezia here. Area of a trapezia is half the sum of the parallel sides times by the distance between them. So I'm going to label these regions 1, 2, and 3. Let's work out those regions as we go. So region 1 I'm going to estimate as a triangle, so half the base times the height. So I'm just looking really carefully at what the height of this is. So you can see that 5 is the whole 10 squares, and this is 5 squares here, so this is going to be 2.5. So how much is each square worth? Each square is going to be worth half a unit. So 1, this is 2 up, so half the base is 2, so half of 2, so well, that's 1 obviously, and then times the height, which is 2, that's 2.5, so this must be 2. So 1 times 2 is 2, so that's the units that you've got here. Of course, the units will be meters, because it's meters per second the speed, so it's going to be 2 meters travelled there. The area for section 2 will be a trapezia this time, so we know this one's 2, so 2 plus this one, which is going to be, this looks to me to be 5 exactly, so 2 plus 5 divided by 2, so half the sum of the parallel sides times by the distance between them, so it's 2 between them. So 2 plus 5 is 7, 7 divided by 2 is 3.5, 3.5 times 2 is going to be, well, it's 3.5 is 7 again, isn't it? 7 meters. And then area 3, again, this is 5. We started that off earlier. This height here is going to be, just very careful here, 9, I think. And then half that times 2 again. So if 9 plus 4, 5 is 14. So it's 14. And so the sum of all these. So 14 plus 7 plus 2. So 7 and 2 is 9. 9 and 14 is 23 meters. Is your answer an underestimate or an overestimate? It's an underestimate because you can see that the areas of my trapezia and my triangle was below the area of the graph. So you'd have to explain that your areas here were underneath. So areas of shapes less than the area required. So something like that, you'll have little tiny gaps. Calculate an estimate for the gradient of the graph where t is 8 seconds. So you do get questions like this quite a bit. So this is about rates of change. So again, you just draw I'm just going to show you this real quick. So you just draw a line at the line at 8. So I'm going to draw that real quick, and it's not easy to show you on the video to do it, but I can try my best. So I'm drawing a line there. Nice long line. I'm going to make that, try to get that drawn as a triangle, so you can see the triangle. So I'm going to draw the triangle here, and between there and so there. Okay, and again the distance up here, so between 10 and that's 29.5, so 19.5, so 29.5 rather. No, it is 19.5, 19.5, 29.5 and 10, 19.5. And then the distance across here will be from, just checking where my units are, so 6.12, so be careful with that because each one's worth 2, so I've got to be careful with this one. So it's quite hard to see on this printout, so 2, 4, 6, 8, so 6.8, between 6.8 and 12, so between 6.8 and 12, so I'm going to be really careful with that, so that's going to be 5.2, isn't it? So we're going to do up divided by across, so 19.5 divided by 5.2, that should give me a nice value, approximate value again, but it gives me a value nevertheless, so that is going to be 3.75, and I have tried to demonstrate how I've shown my answer, but 19.5 divided by 5.2 So changing y over changing x. And again, this is an estimate at this stage. And what is it an estimate of? It's an estimate of the acceleration because it's a change in speed over time. So I'm going to make sure I write meters per second squared because it's an estimate of the acceleration. It's a change in speed over time. And with that, funnily enough, is the question for part D. Describe fully what your answer part C represents. It's the acceleration. So I'm just going to write that in there. Change in speed over time. Okay, moving on. We've got one more sheet to do before we're finished on this section of work. And you can see this one first of all. This is quite a complex sine rule question. So this is a triangle. It's got ABC being a triangle. This is 8.4. This is 40 degrees. I hope you can see that all right. Some of those facts are given to you in the question. The area of the triangle being 100 meters squared. Work out length AB. So this is a two-pronged attack problem. The first thing to do is try and take apart the information they give you. So the first thing to say is, because this is a non-right angled triangle, we're working with, for area, we're working with half AB sine C. So half AB sine C. So we know that half AB sine C is equal to 100 because we're told that in the question. We need to find out what the other lengths are though, because we haven't been given all the lengths. That's a bit of a complexity in this particular question. So we have to think about what these lengths are. So we're going to let's call this length here, that's little b, and this length here is little a, and this length here little c. It will be the traditional thing to do because it's opposite the corners of those sides. So we're going to get half of a times b, which is 8.4, times sine c, which is sine 40, and that's equal to 100. Now I've got to work out what my a is. So I'm going to do, just to isolate my a, I'm going to do 100 divided by a half times 8.4 times sine 40. So all of this section, half 8.4 and a sine 40 goes underneath. So again, I'm trying not to touch a calculator too early in this particular problem. I'm now going to grab a calculator and work out what all of these things, what this is. So 100, and again, the good thing about these calculators is you can do it pretty much as you read it. So I'm going to show you what I type into my calculator in just 1 second, but I'm just trying to get it all in there first. So what I've done here, I hope you can see this okay. So I've got the 100 at the beginning, then I've got 0.5 for my half. I've got times by 8.4. So again, 8.4, and then the sine 40 at the end there. So I'm going to press equals, and that gets me 37.04, 10435 meters. It's quite a long length. Sorry, 37.04, Okay, I'm going to look at that and see if it makes sense. Makes sense. It's longer than 8.4, so that seems right to me. So I want to make sure I just got that right. I will just double check it just to make sure I've got it right, because I don't want to make a mistake with this. So I'm just tapping it in, making sure I've got all the right things, and I've got it twice now. So 37.04. I'm happy with that. Now we know this length. Then we know this length. How do we find this length? So this is side angle side. This is the missing length. Sorry, I just did that once more because I realised I was hiding it from you. So side angle side. This is the missing length. This must be a cosine rule situation. So we're going to use the cosine rule formula. Again, I'm going to write down what that is. You will have to learn it, unfortunately. These days they do get you to learn it. Okay, so here is the cosine rule formula. The convenient thing about this one is it follows the general form, so it's not too bad. I do have to use all of the number that I wrote down earlier, so I'm going to write it down, all the decimal places that I got, so that I don't make any mistakes. 8.4 squared minus 2 lots of, and then 37.041043, and then times by 8.4, and then times by cosine 40. So again, I've written down that whole long calculation there, try to write the whole lot down. Now I'm going to start tapping things into calculators and working out what things are. So I'm going to get an expression for c squared, Because there's so much stuff going on here, I would definitely like to do this twice. So I'm going to do this off camera, but I'll guarantee you I'm doing this twice, just so you didn't see it happening. You can see it happening twice. It's definitely happening twice, so that you get a good idea about what it is. Okay, so I'm going to write down these two things squared to start with. So 1442.598904. That's this bit and that bit. Now I'll do this bit now. So 2 lots of 37.0410435 times 8.4 times cos 40. Let's plug that in. And it's 476.701431. So I've tried to write down all of the bits that I saw. Now I'm going to work out this bit. 445989904. 476.701431. Okay, and I get 965.89746669. This is c squared, of course, so I have to write c, which is the square root of all this stuff. So I'm going to square root that to give me an answer, 31.078889102, and that is 31.1 meters to 3 significant figures. Okay, so quite complex because you've got a lot of complex maths to work out. Definitely a very suitable last question. You can see it was the last question in this particular paper. Worth 5 marks. It's quite a lot of marks, but lots of calculations to work out. So easy to make a slip on the calculator and get it right wrong. But my hints are, don't touch a calculator until you really have to. Try to be careful to do everything twice. Try to write down all the different definitions and all the digits as much as possible, because that really helps you. The very last question is this one, number 14, about Alison, who's using a quadratic equation to solve a quadratic formula. You can see it's quite early on in the paper. This is more easier than some of the others we've done today. But she's got the quadratic formula here. Again, this is just repeating something that I showed earlier in the video. So the idea that you have to remember the quadratic formula. So minus b plus or minus the square root of b squared minus 4ac all over 2a. And that's, you've got to make sure you've remembered that. And here you've got, well, because it's minus b and I've got minus 7 here, b must be 7, so that's definitely the case. Because it's 2 underneath and we've got 4 underneath, a must be 2. That leaves c as something we have to find out. Well, if I've got 32 here and this is 4ac, it's minus 4ac. We've got the 2 bits, so we want something that multiplies with that and 4. So if we had 8 there, so 4ac, so 8 times something makes 32. What's the something? It's got to be 4. So c will have to be 4. So the quadratic equation has got to be 2x squared plus 7x plus 4. And we just double check that we get that right. We just double check that gives us the formula. So minus b plus or minus the square root b squared, yes, minus 4ac, we'll get that over 2a, it will work, so that's okay, we're happy. Okay, thank you very much for watching. I hope you found that useful. Good luck in the rest of your revision for the summer, and I wish you all the best for your exams. Thanks, bye.